This slide shows an example of peak picking for ABR waveforms. As you can see, this figure shows an ABR waveform. On the x-axis, it shows the latency, starting from 0 millisecond, and each division is 1 millisecond. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it shows you approximately 10 milliseconds of the ABR waveform. On the y-axis, it shows the amplitude in microvolt. And according to the unit here, it shows each interval is 0.25 microvolt. So for the ABR waveform here, first thing we need to try to find wave phi. So when you look at the waveform as an entirety, I would say here looks more like wave phi for two reasons. One is here it looks more like a 4-phi complex. It's almost like we have wave 4 here and wave phi here. The second reason is here is a sudden drop going to phi prime. And the phi prime is almost the lowest point of the entire waveform. So based on these two reasons, I'm going to say here is wave phi. So I'm going to mark wave phi here. And as a result, after the sudden drop, the sudden slope, its following trough is phi prime. So I will mark phi prime here. So we marked wave phi and phi prime. So now we need to mark 1 and 3. So phi 4, and this will be 3, 2, and 1. So if that's the case, I will mark wave 1 here and wave 3 here. Now you kind of look at the waveform as an entirety to double check. Wave 1 is 3 and phi prime. It looks kind of correct to me. And also we even see wave 6 and 7 toward the end. But 6 and 7 are not the main focus of this class. We will focus mainly on 1, 2, 3, 4, 5, specifically even emphasizing on 1, 3, and 5. So now we also need to pick phi prime so that we can measure the amplitude of wave 1. So now we have 1, 3, 5 marked and 1 prime and phi prime marked. The next thing you need to do is to estimate the latency and amplitude of wave phi. So here, let's see, wave phi is here. Latency, let's count 0, 1, 2, 3, 4, 5, 6, approximately 6 milliseconds. And don't forget, we need to compensate the 0.8 millisecond offset when the sound was traveling in the sound tube. You can also tell from looking at the waveform here, the first about 0.8 millisecond here is flat. There is no brain waves because the sound has not arrived to the tympanic membrane yet. So we need to compensate the 0.8 millisecond. So here is how we do the math for wave phi latency. Before compensation, wave phi is located at 6 milliseconds. After subtracting the 0.8 millisecond offset, we get 5.2 milliseconds. So this is the latency of wave phi. In terms of amplitude, we need to consider two components. First is the baseline to peak amplitude of wave phi. So baseline is here. Going, let's see, is roughly here. Baseline is roughly here, going up a bit less than one interval, and then another one another portion here. So it's probably a little bit more than one interval. So I'm gonna say is roughly 0.3 microvolt. Again, for this class, a rough estimate is good. I just want to make sure you understand the concept and can perform the procedures correctly. So the baseline to peak amplitude of phi is about 0.3 microvolt. Now let's estimate the baseline to peak amplitude of phi prime. The baseline is about here. We have some portion here, and then one entire interval plus another additional portion. So adding them all together, roughly say 2 intervals. So one interval 0.25 microvolt, 2 intervals will be 0.5 microvolt. So here, baseline to peak amplitude of phi prime is negative 0.5 microvolt. Be aware it's negative because the phi prime is situated below the baseline. So now the wave phi amplitude is basically the height from phi to phi prime, or you can say the difference between phi and phi prime. So we will need to do the computation. It's 0.3 minus negative 0.5, and that will give you 0.8 microvolt. The height is basically the baseline to peak amplitude of phi and baseline to peak amplitude of phi prime altogether. In this case, 0.3 and negative 0.5 altogether is 0.8 microvolt. So the wave phi latency is 5.2 millisecond and wave phi amplitude is 0.8 microvolt. Don't forget to include the unit in your answer to earn full credit. Now let's do another example. Now let's practice on wave 1. So wave 1, similar thing. Wave 1 latency is here. Let's count 0, 1, 2, probably 2.4 millisecond for wave 1. Again, a rough estimation is good. 2.4 millisecond, and we have to compensate 0.8 millisecond, and that gives us 1.6 millisecond. And this is the latency of wave 1. For amplitude, same thing, 2 components. The baseline to peak amplitude of 1 is baseline is here up to here, a little bit less than half of an interval, let's say 0.1 microvolt. Again, a rough estimate is good enough. Baseline to peak amplitude of 1 prime, so here we have a little bit of here and nearly 1 entire interval here. So a bit more than 1 interval. I'm going to say 0.3 microvolt. And because 1 prime is below the baseline, it's negative 0.3 microvolt. So the wave phi amplitude, we need to consider the 2 components, 1 and 1 prime. Put them all together is 0.1 minus negative 0.3, and that gives you 0.4 microvolt. Again, rough estimation is sufficient. So for wave 1, its latency is 1.6 millisecond. Its amplitude is roughly 0.4 microvolt. This is how you pick peaks for ABR waveforms. I hope this helps. This slide shows another example of peaking for ABR waveforms. As you can see, this graph shows several ABR waveforms. On top is an ABR waveform recorded at 65 dB. Next, 45 dB. Next is 2 replications at 35 dB. Next, 2 replications at 25 dB. The bottom ones are 2 replications at 15 dB. So sometimes our focus is to try to estimate the wave phi latency. Of course, we also identify 1 and 3 to the best of our ability. So this example, if you look at the x-axis, is time in millisecond. It starts at 0 millisecond, And in this case, each division is 2 milliseconds. So it will be 0 millisecond, 2, 4, 6, 8, 10, 12, 14. So this graph shows roughly 14, 15 milliseconds of the ABR waveforms. On the y-axis, as you can see, each tick, each interval is 0.25 microvolt. So now if you look at everything as overall thing, that you probably will realize that here is likely the wave phi, and with a sudden slope, here is phi prime, phi, phi prime, phi, phi prime, phi, and phi prime. And for the bottom one is, I am not very comfortable to pick wave phi here, so I'm gonna say this wave phi here. So based on this, I will pick 5 here, and here, and here, and here. And I will not pick wave phi here, but it's not. Everybody has different philosophy, and as long as you are consistent, you'll be fine. Some people may be willing to pick here as wave phi. Okay, for this class, either way is fine as long as you are consistent. So now we pick wave phi here, and if you go back, we don't really see wave 4. So here is probably 3, and here is 1. So 1, 3, 5. So let's pick that 1 and 3. So 1, 3, 5, and that looks right. And for the second trace, that will be 1, 3, and 5. For the third one, wave 1 is here, 3. We have 2 replications. I mean, it's up to you. You can pick 3 here if you want. But in this case, I will be quite flexible to your standards as long as you are consistent. And the next one, wave 1, is probably here. I know it's difficult to pick exactly where, but roughly around this region is fine. Wave 3, similarly, it's hard to tell. And the bottom one, I really cannot tell wave 1. So this is the locations I will pick. And in this scenario, if you want to measure the amplitude of wave phi, you will need to pick phi prime. Similarly, if you want to measure amplitude of wave 1, you will need to pick 1 prime. So, but for this example, for the sake of simplicity, let's focus on picking the locations of the 1, 3, 5. And in terms of 1 prime and 5 prime, I believe you can do that yourself. Thank you.